Earthly currents of wind and sea. All forces and currents are a result of the Sun, and these currents help create life on Earth. The Sun is a fiery mass of hydrogen and helium gas, all held together by its own gravity. This gravity then in turn keeps the Earth together, and the heat that radiates off the Sun is then what fuels the Earth as we know. Greenhouse gases lock in this heat and allow the Earth to warm. The Sun's radiation to this Earth then also drives all forces that directly affect the species that inhabit this planet of ours. Forces such as climate, weather, and tide, which I'll all be going over along in this film today. Insolation, which is the Sun's rays, is greatest at the equator. When the suns hit the Earth, it is known as insolation. Due to the tilt of the Earth and its orbed shape, the northern and southern hemisphere experience different day lengths and varying temperatures. The poles then go to the extreme of having either no sunlight or full sunlight, depending whether it is summer or winter. However, the equator, which is at the centre of the Earth, experiences an equal temperature and has very little variation between and no real seasons. This then leads to huge biodiversity. This is because it can be the pressure build-up of the low pressure area around the equator helps build up rainwater by being cooled. This then means that humid rainforests can grow, such as the Congo, Amazon, and the tropic rainforests of Indonesia. The Earth's bulge then also means there are more daylight hours on average compared to everywhere else in the world on the equator, as there is more circumference compared to such places like the poles. Coriolis effect is where wind currents or objects get distorted from travelling in a straight line. This is due to the curvature of the Earth and that it rotates anti-clockwise and orbits the Sun. The Earth is then also spherical, which means that the sun rays which hit the Earth are perpendicular and are met with varying intensities depending on the latitude of the Earth. The equator receives the most concentrated amount due to being more exposed at the middle of the sphere. This heat in turn creates a low pressure band around the equator. The hot air is then forced into a lower atmosphere. The Coriolis effect then means that the cooling air is deflected as it sinks and rises, surface winds creating a continuous circling pattern. Winds in the northern hemisphere deflect to the right, an opposite direction to the spin of the Earth, and in the southern hemisphere, this does the opposite and winds deflected to the left. The equator is at 0 degrees latitude, and as mentioned already, creates a low pressure system. The line of Capricorn and Cancer have a high pressure system. This then buffers the wind cells in each hemisphere, creating a rotating and deflecting cycle of currents. 60 degrees north and south, however, also have a low pressure band, the same as the equator, with both poles having a small area of high pressure, which resurges the currents. These bands that surround the Earth at equal distances spreading from the equator create zones of rising and falling air. These then separate the Earth's pressure system into 3 distinct cell bands. These are polar cells, which occur between the poles and their respective 60 degrees, north or south, and cause air to rise. Then there is a feral cell, which happens between 60 degrees and 30 degrees and causes air to fall. The final cell system occurs between 30 degrees and the equator, 0 degrees, and is known as a Hadley cell, as shown on this diagram. There are then 4 jet streams found across the Earth, 2 in each hemisphere. These are the polar jet streams and the tropical and subtropical. These jet streams are fast-flowing currents that are found in the lower atmosphere. These winds that gather their speed from being deflected to the right in the northern hemisphere due to Coriolis. All jet stream flows west to east because of this effect. Low pressure systems are areas of wind with low pressure at its center. Wind currents will head towards its center as air condenses and rises into the atmosphere and cools. This then becomes mass amount of water vapor, which then become clouds. Due to Coriolis effect, as mentioned earlier, these currents travel anti-clockwise in the northern hemisphere and vice versa in the southern hemisphere. Low pressure systems generally occur near land as it slows the wind down by having the mass landfalls. The low pressure systems then help cyclones across the continents as a result and is associated with cloud coverage. Low pressure cyclones are generally felt more around the tropical regions surrounding the equator due to its low pressure band that is present due to the Earth's bulge, resulting in more intense sunlight radiation. High pressure systems, however, are the opposite, with a higher pressure at the center. Wind is then blown away from the center of this current and swirls in the opposite direction to low pressure systems, so clockwise in the northern hemisphere and the opposite in the southern hemisphere. This air, which is high in the atmosphere, will then drop through the atmosphere to fill the gaps left over by the air, which already has begun to rise outwards. Waves. As we can see, waves that start out in the deep ocean and then they work their way into the shores and continental shelf, which is what we see on our beaches. As these waves are first pushed inland from the strong surface winds that build up out in the strong ocean, which also leads to storms in the winter season. As the waves build up from the constant wind energy forcing itself upon the surface water, it begins to form a crest, and the momentum of the wave carries itself until it breaks out close to the shoreline. Waves carry itself until it breaks on the shoreline, which is what's known as a surf, and is closely associated with sports such as surfing. Capillary waves are small ripples that occur when light winds disturb the water's surface. This results in a rapid fading circle from the point of origin until the energy from the initial impact is used up and weakens back to normal. An example of this is raindrops on puddles. When the force hits the puddle, it ripples out with the energy that's created from that impact. Wave orbitals are what happens when waves hit the shore. If the right amount of energy is supplied, then the power of the wave will result in the water spiraling out upwards from the seabed and moving sediment and water. However, this force is only possible when the distance between the surface and the seabed is less than the amount of energy supplied in a wave. For example, if a powerful wave broke out in deeper water, the substrate would be undisturbed, and the water spiraling would be less turbid. However, in shallow water, if less energy is required for disturbance, you can calculate the speed of a wave by doing distance over time. These lines are what represents the 5 ocean gyres. As I said, there are 5 major ones across the planet. These are the North and South Pacific gyres, the North and South Atlantic gyres, and the Indian subtropical gyres. Gyres are ocean conveyor belts spreading water across the oceans. These currents are then driven by land, big land masses, and Earth's rotation are deflected and rotated thanks to Coriolis force. Geostrophic flow is where the sea water must take its journey from an area of high pressure to an area of low pressure. The force that then pushes this water is known as a gradient force. However, it does this by travelling along areas of equal pressure known as isobars, due to the Earth rotating. As the Earth rotates, Coriolis force comes into effect and acts perpendicular to the rate of flow. This then counterbalances the gradient force. The direction of flow will then change again depending on what hemisphere you're in. Flow to the right in the northern hemisphere and to the left in the southern hemisphere. An example of this is the jet streams. The video here demonstrates how the water correlates around the ocean basins, such as between England and France and the English Channel. An anthrodromic system point is in the center and keeps it the same. There is no tidal range. Western intensification. This is where currents along the western side of gyres in the ocean are intensified and influenced by Coriolis force. As Coriolis is felt more intense and is more intense towards the poles, as the currents head eastward and down, they are diverted to the equator at a much earlier point and spread out over the equator over a larger surface area so water can flow through a larger area. Once these currents get to the equator and head back up again, Coriolis force is weakened greatly, so the water does not deflect back into it as much in the western region of the ocean basin. The same amount of water must then pass through a very much more narrow gap compared to the easterly side, which is spread out. This then results in more turbidity and stormy sides of water on the western side of the gyre, as the centre is more biased in the western region. This has led to the process being called western intensification. Thermocline circulation is the system that reneutralifies and transports ocean water all around the world. The slow currents are in a continuous loop mainly driven by winds and deep water masses of the Atlantic Ocean. The journey with warm salty water at the surface and cooler less dense water at the ocean depths. When warm salty water comes into contact with polar regions, it becomes saltier. This water then increases in density and begins to sink. The heavier water will then travel back again along where it came from along the ocean depths. This water cycle will then go around until it becomes warmed and less dense and can rise to the surface. Again, this normally happens around the equator. Due to the Southern Ocean being the only ocean not in contact with a mass landforce, it has a complete cold water and warm water circular system. This heads west to east. The whole process goes on for around 1,000 years for one singular patch of water. Tides. You get many different types of tides, one being semi-diurnal. when both high and low tides are around the same. You also get neap tides. Neap tides are when the moon and the earth are at right angles to each other, and due to the bulge of the ocean from the sun cancelling out the moon's bulge on the ocean, this then affects the tides because they do not move as much. They are much more stable. This happens twice a monthly period. The tides will then get more drastic as the lunar cycle approaches the full moon, as the moon and the earth align with the sun. Spring tides are where the moon and the earth are lined up with each other in a straight line. This then causes a total bulge to occur, meaning that when the tides come in and out, they go further in and they retreat further out as well. This occurs twice a month on a new or full moon, as demonstrated in the picture below. Anthrodromic systems are systems at their center that have no tidal range and stay constant. They are formed in between the land and every ocean as the water moves from one side to the other, creating low and high tides that get refracted in a curved motion due to Coriolis force. This then creates a spiral effect of wave crests coming out the ocean center, which has no tidal range. The further away the anthrodromic point is from the wave, the more extreme the tidal range will be. The picture below displays some of the more major anthrodromic systems found across the oceans. Thank you very much.